Guess a number. I'm just going to guess the number 100. Now let's move on to the notes. Our goal for today is to be able to use rational equations to solve real-world applications that can be modeled with rational equations. Let's take a look at this problem. Stephanie can jog 5 miles downhill in the same time it takes her to jog 3 miles uphill. She jogs downhill 4 miles per hour faster than she jogs uphill. Find her jogging rate each way. You might be wondering why we guessed a number at the very beginning of the notes. Well, don't forget, my guess was 100. I'm going to talk about kind of a handy method to approach problems like this. These word problems are the quintessential math-phobic problems that you think of. You know, a freight train leaves New York heading at, 120 miles per hour, and a second train, etc. Find the rate of the trains. That's what this problem kind of reminds me of. And let's come up with a strategy for how we can create an equation for this. Let's take our guess. Remember, my guess was 100. The reason I guessed it before we started the problem is because whatever guess you start with doesn't matter. Our goal is to come up with an equation. Once you have an equation, I bet you guys can solve it. The hard part is getting the equation. So let's guess 100. In fact, I'm going to guess that her jogging rate downhill is 100 miles per hour. I don't care that that seems ridiculous. Let's guess that our jogging rate is 100 miles per hour downhill. Now let's read the problem and see what else we would know just based on our guess. Again, it's okay if it's wrong. I'm just trying to generate an equation. She jogs downhill 4 miles per hour faster than she jogs uphill. So if I'm guessing that that's her downhill rate, her uphill rate must be 96 miles per hour uphill. How did we get that? Well, I took 100 and I subtracted 4. Just by what the question said. Again, I don't care that it's ridiculous. I'm just trying to generate an equation. Let's see. Another piece of information that's going to be important is the fact that distance is equal to rate times time. We've seen that come up again and again, especially in this unit while we're talking about inverse variation. But if I know my rates and I know the distances, 5 miles, 3 miles, then I can find the times. And I would like to check to see if the times are the same for downhill and uphill, according to what the problem told us. So let's look at our downhill time. According to my guess, my downhill time, well, time is distance over rate. My downhill time will be the 5 miles the problem told us over the rate that I guessed, which was 100. My uphill time, using the rate that I guessed, and the distance that it gave us, 3, will be 3 over 96. The next thing I have to check is to see if these things are the same. Are the two times the same? Because the problem told us that it had to be. 5 100ths and 3 96ths. You can check that, or just kind of by looking at it, you could see that my original guess wasn't correct. I could go through the same process again. Let's take a different guess. How about negative 17 miles per hour? Again, it doesn't matter what your guess is. We're just trying to pick a guess and then apply the criteria in the problem and see if our guess worked. Through this process, we can generate an equation. Let's think about what we actually did, because I don't want to have to go through and guess again and again and again and again. Let's see if we can just generate our equation. This time, I'm going to let my guess for downhill rate. I'm going to let that be x miles per hour. In which case, the uphill rate, according to the problem, has to be x minus 4. I can really see that from what we did up here. X and x minus 4, 100 minus 4. That means the downhill time is 5, again it gave us that distance, over our downhill rate, 5 over x. Which means our uphill time is 3 over x minus 4. And according to the problem, we need these to be the same. Can you already see the equation? What we're essentially going to do is take 5 over x and set it equal to 3 over x minus 4. That equation doesn't look so bad to solve. In fact, we can just cross multiply right away. 3x equals 5x minus 20. When you go through and solve, we get that x minus 4 is equal to, we get that x equals 10 here, in which case x minus 4 is equal to 6. So these are our two rates, 10 miles per hour downhill, 6 miles per hour uphill. I didn't spend a ton of time talking about how we solved that equation because we should know how to solve rational equations. I think the real answer here, the real thing that we're concerned about is generating this equation. Once you have the equation, you should know how to solve it, but getting the equation is the tough part. Let's think about what we did again. We took a guess. We applied what we knew was true in the problem, and then we checked it. And with my guess of 100, our downhill and uphill times were not the same. So eventually I said, let's just guess x, in which case we can generate our uphill rate, x minus 4. We generated our two times using our equation distance equals rate times time, or just manipulating it, time equals distance over rate, and then checked if they're the same. The same means that we're going to set them equal. There's our equation. With problems of this form, it's usually pretty easy to go through these steps and do it. We just have to read carefully. Let's do another example. This doesn't have to do with distance, rate, and time, but it has to do with combined rates. Adrian can weed the garden twice as fast as his son Philip. Together, they can weed the garden in 3 hours. How long would it take each of them working alone? So if you think about rate versus time, if you multiply your rate and your time, well, it's not really distance here, but it's number of gardens that have been weeded. So you could think of it as rate times time equals jobs done. So let's take a guess. I'm going to guess that how long will it take each of them working alone? So I'm going to guess that it takes Adrian, any guess you want, 100 hours. There's my guess. I don't care that it's ridiculous. I'm just trying to generate an equation. Well, according to the first bit in the problem, he is twice as fast, which means it would take Philip 200 hours. All right, so now together they can weed the garden in 3 hours. Let's think about each of their rates. Adrian's rate, looks like I spelled that wrong. Adrian's rate is 1 garden per 100 hours, if I'm thinking of gardens per hour. Philip's rate is 1 garden for 200 hours. Their combined rate is the sum of their two individual rates. We're just adding their rates. We're allowed to do that if you're, doing so many gardens in so many hours, and someone else has a different rate, then the rate at which you work together is just the sum of those two individual rates. All right, so it says together they can weed the garden in 3 hours. So if I take their combined rate and I multiply it by their time, which according to the problem is 3, they should have completed 1 garden, right? They weeded 1 garden in 3 hours. So their combined rate times their time equals the number of gardens that they weeded. Now, is this true? It's just numbers, because I just picked a guess. And if you add 1 100th plus 1 200th times 3, we're not going to get 1. You can check that on your calculator if you don't believe me. So that's not really what we want. So let's go back and see if we can generate an equation. Let's instead guess Instead of 100, let's guess x hours. Well, Philip was twice as fast, so that's now going to be 2x hours. So Adrian's rate is now 1 garden for x hours. Philip's rate is now 1 garden for 2x hours. Their combined rate is now 1 over x plus 1 over 2x. And we now have to take their combined rate, multiply by 3, and have it be equal to 1. I'm going to erase these question marks so I have more space. Take their combined rate, multiply by 3, and that better be equal to 1. Now I can solve for x. And if you look back at the top, I can see what x stands for. X was Adrian's time. Let's solve this equation on the next slide. Let's see, 1 over x plus 1 over 2x times 3 equals 1. I can distribute that 3, and we get 3 over x plus 3 over 2x equals 1. Common denominator is 2x. We get 6 over 2x plus 3 over 2x equals 1. 9 over 2x equals 1. X equals 4.5. Right? So it takes Adrian 4.5 hours, and it takes Philip twice as long, so 9 hours. There's our answer. Again, I'm not so concerned with the actual numerical answer. I would like a way just to generate these equations. What we just did, that whole process of guessing and then checking and then realizing where that x would replace your guess, is known as guess, check, generalize. So I'll refer to that method as guess, check, generalize. Take a guess, see if it works. If it doesn't, which it probably won't, pick another guess, pick another guess, pick another guess, until you're tired of guessing and just guess x. Then you're generating your equation, which I think is the hardest part of these. The solving isn't so bad. Good luck!